Graph databases are often considered more efficient than traditional relational databases for certain types of data and queries due to their inherent structure and the way they handle relationships. Here are some reasons why graph databases can be more efficient in certain scenarios: native representation of relationships, optimized query performance, schema flexibility, reduced join operations, scalability for connected data, traversal efficiency, use cases. Graph databases are designed specifically to handle relationships between entities. In a graph database, data is represented as nodes, which can represent entities, and edges, which represent relationships between entities. This native representation makes it natural and efficient to traverse and query relationships. Queries that involve traversing relationships can be more efficient in a graph database compared to a relational database. Graph databases use specialized algorithms like depth-first search or breadth-first search to navigate relationships quickly, leading to faster query performance. Graph databases typically have a flexible schema that allows entities to have different types of relationships without requiring a predefined schema. This flexibility is advantageous when dealing with evolving or dynamic data models. In relational databases, complex queries often involve multiple joins to combine data from different tables. Graph databases, on the other hand, can represent complex relationships without the need for extensive join operations, which can significantly improve query performance. Graph databases excel in scenarios where data has complex and interconnected relationships. As the size of the dataset grows, graph databases can maintain performance because they focus on efficiently navigating and querying relationships. Traversing relationships in a graph database is typically more efficient than navigating through tables in a relational database. This is especially true for scenarios where the depth or complexity of relationships is a key factor. Graph databases are particularly well suited for use cases such as social networks, recommendation engines, fraud detection, network analysis, and any application where relationships between entities play a crucial role. When assessing whether a company could benefit from implementing a GraphQL database in its IT infrastructure, it's essential to understand the specific needs, challenges, and goals of the organization. Here are some questions you might ask the CEO the following. What is your current data architecture? How is your company's current data architecture structured? Are you facing any challenges with data retrieval and management in your existing system? What is your application ecosystem? What types of applications does your company use or develop? Web, mobile, APIs? Do you have multiple applications that need to share and consume data? What is your development workflow like? How is the development workflow in your organization? Do your developers face any issues related to overfetching or underfetching of data? How complex is the data structure within your applications? Are there nested relationships or dependencies between different data entities? What are the requirements of your front-end applications in terms of data fetching and updates? Do you need to optimize data fetching for specific user interfaces? How flexible does your API need to be in terms of data retrieval and mutations? Are there scenarios where clients need only specific subsets of data? How are your backend and front-end development teams currently collaborating on data requirements? Have you faced any challenges with data versioning and compatibility? Do you anticipate significant growth in data and user traffic? How important is scalability in your IT infrastructure? Do you have legacy systems that need to be integrated into modern applications? How do you handle data migration and compatibility with older systems? Do you see adopting newer technologies, like GraphQL, as a potential competitive advantage? Are your competitors or industry leaders leveraging GraphQL or similar technologies? How important is developer productivity and ease of development in your organization? Have developers expressed interest or concerns about the current data fetching mechanisms? Are you willing to invest in training and education for your development teams to adopt GraphQL? How open is your organization to embracing new technologies and methodologies? These questions can provide insights into the specific pain points, requirements, and aspirations of the company, helping to determine whether GraphQL is a suitable fit for its IT infrastructure. It's important to note that the choice between a graph database and a relational database depends on the specific requirements of the application and the nature of the data. While graph databases excel in scenarios with highly interconnected data, relational databases may be more suitable for certain structured data models and transactional workloads. The efficiency of a database system depends on how well it aligns with the characteristics of the data and the types of queries expected in a given application. Thanks for checking out this summary on graph databases. Do you think your company could benefit from adding a graph database to its workflow? Leave a comment below and subscribe to stay up to date with the latest AI and machine learning updates.